Question 1. Coconut oil contains a triester of three identical R groups. The triester reacts with potassium hydroxide. A complete equation by drawing the structure of the other product of this reaction in the box. So, what we're going to have in the box is we're going to have the CH2s and the OHs. Because think about it, this RCO and the K, there's three of them, so that's there, so the rest must be that. So it's just like learning these key patterns, and so you know exactly what to do. CH, OH, CH2, OH. There we go. The type of compound, well, it's going to be a salt, and it's going to be a carboxylate salt. Carboxylate salt, and the use is a soap. So, like these two, I'll just say one question, 3 marks. Carboxylate salt, soap, and then drawing this. Well, the only way to how to draw it is by knowing the reaction. But also you could know how to draw it because you see the RCO and the K, and therefore remaining is the CH2, CH2, and the 3 OHs. And then it says the triester in coconut oil has a relative molecular mass MR equals 638. In the equation shown at the start of the question, 1R represents an alkyl group that can be written as CH3CH2N. Deduce the value of N in CH2CH2N, show you're working. Well, it's question 1.2, can't be that hard. It definitely should not be that hard. We know the triester in coconut oil, which is this is a triester reacts with potassium hydroxide. So this triester, this potassium hydroxide, has an MR of 638. So let's find out the MR of COO, CH2, all of this. So I got the MR as 173, so 638 minus 173, which will give me 465. And now that's 465 is for all 3 R's, which is equal to 3R. We just want 1R because it says R represents an alkyl group that can be written as this, so 1R. So R is equal to 465 divided by 3, 155. And then if we look at this equation, MR of carbon is 12 plus 3 hydrogens, so 15 plus 12 plus 2, 14N. And we know that is equal to R, which is, we worked out as 155. 55. We get 14N equals 140. Therefore, N equals 140 divided by 14, which is 10. There we go. Question 1.3. Calculate the percentage by mass of the triester in the coconut oil. So first things first. Before I even, there's a lot of information given in the question, and anytime there's a lot of information given, try to just find the moles of everything you can. So the moles of, let's do potassium hydroxide, mass over MR, 0.421 over the MR of potassium hydroxide, which is 39.1 plus 16 plus 1, and we get the moles as 7.50 times by 10 to the power minus 3. Number 2, find out the moles of HCl. And you might be wondering, well, we aren't given mass, so the MR of HCl. No, but we're given the concentration and we're given the volume, and we can therefore we're given the concentration, we're given the volume. Therefore, we can use moles equals concentration and volume, so 15.65, but we want it in moles per dm cubed, so we want to divide that by 1000 times by 0.100, which is already in moles per dm minus cubed, and we get 1.565 times by 10 to the power minus 3. Now, if we want to work out the amount of potassium hydroxide used, we're going to do 7 KOH used. We're going to do 7.50 times by 10 to the power minus 3 minus 1.565 times by 10 to the power minus 3, which will give me 5.935 times by 10 to the power minus 3. Now here's a trick after here. Many students will maybe get up to here, or maybe at least stage 2 or stage 3, but we want of the triester, right? And we know that the ester is not 3, potassium hydroxide is 3. The ester is that divided by 3, it's a third of it. So amount of ester, or the moles of ester, is going to be 5.935 times by 10 to the power minus 3 divided by 3. That is the end of question 1.